Smart pointers, an extremely important topic for any C++ interview. Usually in C++ interviews, you are asked to implement unique pointers or shared pointers. In last video, we already saw what are smart pointers, why do we need them, and we also saw the implementation of unique PTR. So if you have already watched that video or if you know about unique PTRs, you should be able to follow up in this video because we'll be talking about how to implement shared pointer and we'll discuss exactly why we are writing the code as we write it. So I hope you're excited, and yes, my ex-boyfriend is here to help me out. So let's get started.
So we'll start with the shared PTR implementation as we always do. We'll start with the requirements first. Okay. So somebody can say shared PTR of int.
It can be of any data type, even
Yes.
user-defined data type.
Correct. So somebody can say PTR1. Okay.
Because it is integer, we'll pass integer.
Yeah. Okay. But let's start with simple PTR1. Somebody can say like this also, PTR1. So how do you think this gets implemented? This is simply a default constraint. Correct. And now somebody can say shared PTR of integer and PTR2. Correct. And now he can say give a resource like new int of n. Correct.
This is parameterized.
Correct. This is a parameterized construct. Now somebody can say shared PTR of int and PTR3, and he can go ahead and write it as PTR2 initialize with the other shared PTR. So how do you think we'll be able to implement this?
Copy construct.
Correct. Copy construct. Right. And then somebody can say
Assignment.
correct. So somebody can so now in assignment what will be there, like we can say
PTR3 equal to PTR2 or
correct.
PTR4 equal to PTR3.
Correct. PTR3 equal maybe somebody can say PTR2. So how this gets implemented?
Assignment.
Copy assignment operator. Assignment. Okay. Operator.
Before we go ahead, I would just like to share with you that PW is launching 4 job assurance programs, namely Full Stack Data Science Pro, Mastering Full Stack Data Analytics, Full Stack Web Development, and Building Microservices in Java for Cloud that guarantee not only learning but also interview opportunities with top companies. Full Stack Data Science Pro batch will immerse you in AI from machine learning to deep learning, computer vision, and NLP. Plus, you'll be learning emerging domains like prompt engineering via OpenAI's research work. For those interested in full stack web development, you'll master MERN stack and build complex websites like Netflix, Insta, and YouTube. For full stack data analytics, you will learn Python, SQL, Power BI. Similarly, for building microservices in Java for cloud, you will master microservices, DSA, design patterns. They are offering guaranteed interview opportunities for up to 9 months after course completion, round the clock doubt support, realistic terms, and 50 plus real time projects. Additionally, they have live doubt sessions, unlimited access to PW Skills Lab, and entry to the PW Skills Job Fair and Experience Portal. You can check out the dates and you can use my coupon code for extra 2000 rupees discount on the PW application.
And what about this? So somebody can say shared PTR of int and PTR4 and then give it std move of PTR1 maybe. So how do you think this gets implemented?
So now the ownership is from PTR1 to this new PTR that we are passing to, which is PTR4.
So how do you think this gets implemented? So this gets implemented using move copy constructor. Correct. So there is a difference. This is simple copy constructor and this is a move copy constructor. Okay. And again similarly somebody can say PTR2 equal std move of maybe let's say PTR3. So how do you think this gets implemented?
Move assignment.
Move copy assignment operator. Okay. Apart from this, we can have APIs like ptr1.reset. So someone can reset the resources, and if you don't give anything, they will be set to null, right? And we can have API similar to this as reset with some resource. So if they
Different file.
but with a different resource, correct. So somebody can give this, right? Now what else? So as we have seen in the pointer, we can have a star of this will do or PTR arrow operator will do, right? So we have to implement that also. So how will we do this? So somebody can see ptr of 1. So it means value of that which is it is pointing to. Somebody could say that like this, correct? And somebody can say like this, ptr1, and call some function. So right now this might not be applicable for an integer, but for a user defined type, that user defined can have a function like func. So he should be able to call that through that ptr, right? So we should also be able to implement this operator. So this will be done through implementing star operator, and this will be done through implementing arrow operator. So there will be something called ptr1 dot get, which gives the raw pointer which it is pointing to. So the raw pointer. So there is one more thing that we have to implement in shared ptr, which was not there in unique ptr. So can you guess what was that?
So in unique PTR, there is exclusive ownership. Over here, there will be shared PTR will be used for multiple resources. So probably something like get count, I'm guessing.
Correct. So we should have an API called get count. So number of objects pointing to the same resource. And of course, our customary destructor. Correct?
Yep.
Delete the actual resource. So let's implement this.
Yes.
So everything else is almost same, but we'll see what is the main difference that is different from the unique PTR implementation here. Because it is a templated version, so we'll write our template code. So how do we start? Template, type name P.
This we are writing so that we can support any data type, not just integer.
Correct. And our name is shared PTR. The actual steady version of it is shared underscore PTR. Just to make it different, we are writing shared PTR. Correct. So we'll have private and public section. Correct. So we'll have a member as t star resource, which is obvious. We'll be keeping the resource inside this. And there will be one more member, which we did not have in our unique PTR. Can you guess what it is?
Counter.
Counter, correct. But how do you think we'll put our counter? How do you think we'll count our counter? Like number of objects pointing to the same resource, right? If I put it as int counter, do you think it suffices that we'll be able to count that? Let me explain you with the diagram. So let us understand this with the diagram.
Yep.
Okay. So what we have drawn earlier also, we'll draw a simple stack memory for a process and the heap memory. Okay. And suppose our code was class shared ptr, and we had to t star one resource was there, and we have to count this resource, how many objects are pointing to the same resource. So suppose we keep a counter here to count it. So what will happen? So anytime new shared ptr object is formed, shared ptr object, suppose one object one is created. So what will happen? These two will be created new, right? So this resource and this counter will be created on stack, right?
Yep.
And this resource will be pointing to some resource. So suppose inside this we'll do a new int, right? So suppose this is 5 and this is some memory address bcd11, suppose, and this resource will be pointing to this memory address. That is good, but what about this counter? So suppose this shared ptr object 1 is pointing to this particular resource, and we have incremented this counter plus plus in our algorithm. So now this counter's value has become 1. Now suppose we make a new shared ptr object and object 2, suppose, for a different resource altogether. And suppose we make a new shared ptr object 2 and want to point it to the same resource. So what we'll do? We'll do a object 1. We'll make it equal to this. But what happened to this counter? This object 2 will have its own resource and own counter, right? This resource will make it point to this one. But what about this counter? If we make counter plus plus, it will isolate it, it will make counter 1 here. But what about this? This is 1 here and this is 1 here.
Then it should be 2.
So each object will have its own counter, right? So that's what we don't want. So what do you think? How do we manage this thing? If not counter, how do you think we should be able to implement this thing?
We can use a static because that is not per object and that is for class.
Correct. So if you take it as static, what will happen now? So this counter has become a particular to a class, right?
Yes.
So every time you create an object, this counter will increase,
Yes.
right? If your algorithm is counter plus plus,
Mm-hmm.
correct? So suppose shared PTR object 1 you created, you did counter plus plus 1 and your counter became 1. Suppose another object you created shared pointer object 2 and you gave it to this object 1, your algorithm ran fine, it became 2. But what if you created a new shared PTR and object 3, I want it to point it to some new resource. It is not the same resource I want to point it to. But what will happen now? Your counter will become 3, right? Because it is per class. So it is wrong, right?
So it should be per resource.
Per resource. So how do you think we should be able to implement this? So to implement this so that we are able to count per resource, right? So what we'll do is, let me drop this one out, and we'll put an integer counter. Why this integer pointer is important? If we understand this, shared pointer implementation is done. This is the main problem that comes while understanding shared PTR. Okay, so why counter? Why integer pointer to count? So suppose if we put an integer counter, so now in this diagram, let me redraw this again, stack memory. So we again have some stack memory. Now we, instead of integer, we have integer counter. Okay, so again we have res and we have a counter, but this time counter is not the simple counter, but it is a memory address. It will keep a memory address. So suppose we have new resource is created for this on heap and for counter also. Okay, and this counter will point here and this resource is pointing here. This counter is pointing here and this resource is pointing here, right? So now I created an object first time. This is pointing to this resource. Our algorithm will become star of counter plus plus, which means what? This value will increase. So this will become 1. Suppose we created second object and we pointed it to the first one. So again, with our algorithm, this will become 2, right?
Yep.
So
So now if we create another shared pointer for a different
different resource. So what it will have its own race and it will have its own counter, which again will point to some other resource here and counter here, like this. And this will have its own count going on, correct? So that's why we need a pointer, not a static and not a simple count, right? So let's go into the code and see how we'll implement this.
For quick revision, so we cannot use a static because then we won't be able to see per resource. We will just see for generic class.
For per class,
for
correct.
per class.
Yeah.
And we cannot use normal integer also because then it will be per object then. So we want per resource but on a class level. So that is why we have a integer pointer. So for every resource we are increasing the count.
Correct. So let's go to the code.
Yep.
So now we know that why don't we need just a simple integer? We need an integer pointer to count the number of resources. So let's start our implementation. So we'll mix the default and parameterized constructor into one. Let's start with the shared PTR constructor. So we'll start with shared PTR template T star and let's give it an MPTR and let's give it a resource of uh, PTR.
Okay, so initialize a list.
Correct. And what will give the counter? Let's start with giving it a new int of 1. So every time somebody calls, we'll give it a 1, right?
Should we start with 0 or with 1?
My implementation will be like, so anytime somebody says shared PTR of int, even if it doesn't give any resource, I'll point it as you have started with 1 resource, something. So that while deleting, I'll know ki, okay, if somebody is going out of scope and we have to delete this, I'll just subtract that counter. So you will see the implementation why.
Okay.
Okay.
So it depends on the implementation. We could have also started with new and 0.
Correct. We could have started with. Correct. So I'll just write a simple constructor so that we know that constructor was called, right? Nothing fancy here. Just to implement this one, default and parameterized constructor in one, what I will do is I'll give it a default value, null PTR suppose. So if it doesn't give anything, it will be taken as null PTR. So these two implementations are done, correct? So you can see that there is no error coming now. To implement the parameterized constructor, we just write C set PTR and P of the other shared PTR will come here, and we can write this like this ampersand PTR. We also have to write a const here in
Pass by reference and const. Okay.
correct. So what we'll do in this? So now we have two people are pointing to the same resource, right? Copy constructor will come when we write this statement. So there is PTR2 already pointing to someone, and now PTR3 will also be pointing to. So what we have to do in this case?
We have to increase the count.
Correct. So resource equal PTR dot resource. Correct.
Okay.
And now?
So both are pointing to the same resource now.
Correct. And again, the counter also has to point to the same counter, right?
Yeah.
We saw in the diagram. So
here, whatever PTR we passed, that ka resource, we are pointing to this ka resource.
correct.
Similarly, for counter, whatever was the PTR ka counter, same thing.
Correct.
Pointing to this.
Both pointing to the same counter. But now what we have to do? We have to
Increase the
increment the
counter.
count. So what we'll do is we'll just write a increment counter function so that we don't have to write it every time, right?
We could just do plus plus.
Yeah, I'll tell you why. And we'll make it private. So other don't have to use this, right, publicly. So we'll make it a private function. So increment counter will give, and we don't have to return anything. So void. And in this, what we'll do is, because both are now pointing to the same resource, so what we'll do is star of counter plus plus.
So increment the value because counter is a pointer. So whatever it is pointing to, increase the value
Correct.
by 1.
Yes. And also because now we know that counter is a pointer. So just to have a good programming sense, we'll check if it is there or not. So to avoid any errors, right?
Because it could be null.
Correct.
Worst case.
Yeah. So defensive programming. Makes sense?
Yep.
So similarly, now we have written increment counter. We'll also write a decrement counter function here only. And we'll see why. Decrement counter.
This will be whenever we remove one pointer pointing to that resource.
Correct. So in that case, we have to decrement the counter. And we'll later in the program, we'll know when we are calling this. So what will happen in decrement counter? We'll first check if counter is there or not. Like above, right? So if it is there, what we have to do? We have to decrement, right? Star of counter and then minus minus.
Yep.
Correct. But now if we do a subtraction, and what if now the counter's value is 0 after decrementing? So suppose two objects were pointing. So one object started pointing to someone else. So now this only one object remained. Now this also went. So its counter becomes 0. So what will happen to that particular resource now? It should get deleted.
Yep.
So what we'll do is we'll keep a check.
If the counter becomes 0.
Not counter, but if star of counter becomes 0. Yeah. So if star of counter becomes 0,
the value becomes 0.
Value becomes 0, not the address, right? What we'll do in this case, we'll delete the resources. So we'll delete what? And because the resource is also a pointer, just to have a defensive programming, we'll check if it is resource is there already, then we'll delete this resource. Fine. And also we'll delete the counter.
So now, because we are using smart pointers, we don't have to take care of deletion and all explicitly.
Correct.
By default, it will take care of this.
Delete the resource and delete the counter.
Both are pointers, so we need to delete.
To be a better programmer, we can just point it to a null PTR. Correct? Yep. So now this increment counter, our parameterized constructor was done, right?
You said you will explain why we are writing a different function and we are not doing it.
Yeah, so in this case, if you see, we have to do a lot of checking, like if counter is there not, if a star of counter plus plus. So I don't want to write this because we'll be needing this increment and decrement in other places also. Like if we implement these functions, like copy assignment and copy move copy, we'll need this increment and decrement. So I don't want to
Write it
keep
again.
thinking about this if it is goes null. So we have made this at one place.
Modular.
Okay. So now, our copy constructor is done and parameterize and default constructor is done. So what next? Our copy assignment operator, right? So in this, the signature is shared PTR of T and ampersand, and then write operator equal, and then const shared PTR of T ampersand PTR. Correct? We can omit T if you want. Like some people just omit T. That also works, but just for the
Clean implementation.
yeah, I've just written it. Okay, so what will happen in this case? It's the say a similar implementation what we have done in other copy constructors like string class and all. So we in this what we do is we first check if it is not the if this is not equal to ampersand of
Yeah.
PTR.
Basically, we are not trying to point
Self
to the same
assignment.
thing. Yeah.
Self assignment we are checking.
Yeah.
And at the end what we do in this case is we return star of this, correct, and then we'll think what should happen in this case. So somebody assigning to so this statement, right?
PTR 3 equal to PTR.
Copy assignment. So this was already initialized and this has already been initialized, but now PTR3 is trying to point to some other resource.
Yeah.
So what will happen in this case is PTR3 will leave its own resource and then start pointing to the PTR2's resource.
So we'll have to decrease the counter for PTR3 and increment the counter for PTR2.
Correct. Okay. So before pointing to the other one, I will have to decrement my first. Correct. So what we'll do is decrement.
Okay. So now all the checks are happening within the function, so I don't have to worry about.
Correct. So I did a decrement. So see, suppose after decrementing, if this object was the only one pointing to that resource, its counter would have become 0, and in that case we would want it to delete the resource, right? So decrement counter done. Now what we should do? Now we should start pointing to the newer whatever that came in PTR, right?
So PTR.
So what we'll do is res equal to PTR dot res, correct, and counter equal PTR dot counter. So now I've started pointing the counter to the new counter that has come through this PTR.
So both are pointing to the same resource and the same counter.
So I'll just do an increment counter. Correct? Does that make sense? Right. So now our this operator copy assignment operator is done. So after this, what is left? Move copy constructor and move copy assignment operator. So what we'll do is we'll just copy this and we'll see what we have to change. Okay, we'll just put it here only. So this is move. We're trying to do a move copy constructor first. So in copy constructor, we don't need a const, right? Because we'll be changing the PTR itself. So what we are doing in the move, and in this for the move signature, we do a double ampersand. So what we do in a move, we take the whole resource from this PTR and pass it to the this wala resource, right? And this will start pointing to null, right? It will move its resource.
Moving the ownership from one pointer to another point.
Correct. So in this case, what we'll do is res will start pointing to the res, this res,
PTR
correct. Counter will start pointing to the other counter, right? But do we need an increment counter here?
Counter is same only.
Why? Counter is same now?
Because earlier there was another pointer who was pointing to this. Now there is a new pointer who is pointing to this. We are just moving the ownership. The counter is still the same.
Yeah, it's think of something like this. I was pointing to something else. Now some other one is pointing to this, but this is now leaving it. So this another is pointing to this means +1, but this is leaving, so -1. So
+1 -1.
+1 -1, right? Yeah. So I have done this. I have done counter equal PTR counter, and after this, what we'll do is we'll destroy the other ones, right? Yes. So what we'll do is ptr dot resource equal null. Now this will not point to anything else.
Yes.
And
Now
then
PTR is not pointing to that resource, but this new pointer is pointing to that resource.
correct. So this is the move copy constructor implementation. Simple enough.
Yeah.
So we are left with move assignment operator, right? So what we'll do is we'll copy this one and we'll start implementing it. So what we'll do is first remove the const. So we have the signature of move assignment and double ampersand. We'll decrement the counter because now we'll point to something else. So this which was pointing, we have to decrement this, right? So
In
decremented.
constructor, it was not pointing to something, so we did not have to do this.
Yes.
But in assignment, it is pointing to something, and now we have to
point to something else.
Yes.
So we decremented our own, which we are pointing to. Now will start with pointing to someone else, right? So this we are pointing res to pointer res, counter to pointer counter, and now we don't need this increment counter. Why?
Yes. Because
But this was coming, what this PTR was there, what it was pointing to, it will leave its resource, and now we will pointing to resource. So +1 and -1, right?
So leaving the resource, we have to point it to null now, right?
So yeah, we have to point it to null. So PTR dot resource is
null
PTR, and PTR dot counter is
also null
PTR. Counter is null PTR.
So now PTR is not pointing to something, but this new pointer is pointing to the same one. And we have to decrement the pointer. Why? Because both of them were pointing to something. Now only one is pointing. PTR is not pointing to anything.
Correct. So the next one we have reset. Yep. So we'll implement reset here. So it doesn't return anything. So void reset. Correct.
Yeah.
And in reset, what we'll do is, so one object is already pointing to something. So now we are trying to reset to some other new resource. Okay. So in this we have to passes t star of new kind of resource. So let's say PTR. And what we'll do is, now this object was already pointing. So because now this will be leaving the object what it was pointing to and point to something else. So we have to do is decrement what it was pointing to, right? So decrement the counter, right? And then point it to the new one. Yep. Correct. But now this was pointing to something else. Now it started pointing to the new resource, like new integer. So it has to create a new counter altogether. It cannot use the same old counter, right?
So we're resetting the value.
Yeah. So what we'll do here is counter equal new int of 1. We'll start with the new. This is a fresh one. That's why 1. Yep. Correct. And this is what the implementation of reset looks like. We have reset to new resource. Correct. So what left is get count. Correct. So what we'll quickly do a get count. So it should return an integer and get count. Correct. And what we should return here?
The value of the counter.
Return the value of the counter. But just to have a defensive programming, we'll just check if counter is there already. If counter, then return star of counter. Correct.
Remember, counter is a pointer, and main point over here is to understand why it is a pointer.
So the next one is operator. So this operator will implement operator this, and what it will return is simply the pointer. So t star. Correct. And this won't take anything, and we have to just return this. Correct. So the next what we'll implement is operator star. So what this should give the value at which it is pointing to, right? So this is t ampersand, the reference to that value, right? Yep. So this should return star of resource, what it is pointing to, the value actually. Yep. Okay.
So here RES could have been null, but then the check should be on the application layer.
Yeah. So think of it like this. So when you have a pointer new int, when you do, you always check, right? If res is there, then you do something, right? So similarly, if somebody is using our shared PTR and if he has already deleted it and then he is doing star of this, it should actually give you an exception. That is by design, it should give you an exception if you're doing this. Okay. So that check should be at application level. That is how I am designing my shared PTR.
Similarly, in the getCount function, we are returning like only if the counter is there, we are returning the value,
Yeah.
but then it can be null. So, but we should be returning some value, right?
Correct,
Because we are
correct.
supposed to return
Right now, this should give us some error because we are not returning anything the else part.
Yes.
So we should have something like return -1, or we
should
could
throw an
also
error.
have an implementation like throw the error,
Yeah.
right? So we could do it like this, but right now I'm doing is -1.
Yeah.
So the next remaining is get. That is very simple. We just have to return the actual pointer. So get and just return the resource. That's it. And after this, what left is our destructor. So what we'll do is shared PTR. And what do you think we should do in this? So once we are going out of the scope or we are deleting it, right? So we'll not say delete because the actual shared PTR will be on stack.
Yeah.
So they will be deleted when they are goes out of scope, right? We have studied this in unique PTR. Right?
Yeah.
So in that case, what it should do is when it goes out of scope, whatever this object is pointing the resource to, it should decrement the count, not delete it, because they might be pointed out by someone else, right?
Yep.
So what I should do is decrement the count. And if you remember correctly, this decrement counter, it will take care. If it is the last one pointing, if the count becomes 0, it will automatically deletes all the resources, right? So this is the one line. Remember, why do we need to write a modular code? Correct? So, I mean, this is all we have to do for the implementation of the shared PTR. What, again, the same as unique PTR, what left was, what we have missed in this implementation is we could actually give it a separate deleter function and separate allocator function, which is there in the standard C++. And that itself is a very simple implementation. We can just simply give a deleter here as a one more parameter, and we could just, instead of doing a delete ourselves, we could just pass this resource inside that point function, deleter function. So that is one thing that we have omitted, and similarly an allocator function, and maybe something as multi-threading we have not taken into account. So that we have said similar thing in unique PTR. So yeah, that is it from my side, implementation of shared PTR.
But this looks awesome. Thank you so much for coming and doing this.
Thank you.